Hello geometry students, and welcome back to another video lesson as we continue to explore perimeter and area. Today we start to begin focusing on the area aspect of different types of polygons and irregular polygons, and really look at coming up with formulas for area so that we can apply them and use them either on a coordinate plane, so on graph paper, or in real situations, so to speak. Okay, and so we really need to look at how do we come up with different types of formula and the formula for them. So here is an example where we're going to look at finding area on a coordinate plane. Given the following figure that's down here, find the area. We're not going to worry about labeling it at this point. It should be units squared, whatever we get, but we need to find the area of this entire shape. And the small problem in this is that it's not just a regular rectangle. It's not necessarily a square or a kite or anything like that. It's an irregular shape. And so remember, area covers all of the stuff that is on the inside of this shape. So all of this stuff here that I'm going to kind of color in red quick, that's the area. And when we're on a coordinate plane, and typically we have graph paper, we have all of these lines that are going to be on it somewhere, right? And as long as they're counting by units of 1, we could count each one of these boxes, if you will. I'm going to draw that one all the way across as well. Right? We could count every single box to help us find the area of this entire shape. Because each box measures 1 by 1, right? According to the graph down here, the grid, this is a measurement of 1, 2, 3, 4, so 1, and this is a measurement of 1. So this box has an area of 1. This box has an area of 1, and so on, all the way through this entire picture. Well, that is easy for us to then look at if we're on graph paper to help us figure out how many total boxes there are, right? 2, 4, 6, 8, 10, 12, 14, 14 that way. Then if I count from here, 2, 4, 6, 8, 10, 12, there's 14 more over here, plus there's 4, 5, 6, 7, 8. So 14, 14, and 8, if I'm just solely counting those boxes, 28 and 8 is 36 square units, 36 whatevers. But what we might find more practical is trying to break up this shape into as many rectangles as we possibly can. We should know that the area of any rectangle is base times height, length times width, whichever one you prefer to use. And so if I just try to break it up into rectangles and or squares, notice I have 4 different rectangles / squares. This one is 2 by 1, 2, 3, 4, 5. 2 by 5 means this rectangle down here has a total area of 10. This top rectangle has a height of 2 and a base of, from 1 to 10 makes that 9. So this one would have an area of 18. This has a 1 by 1, 2, 3, 4 by 4, meaning it has an area of 4. And the bottom one is 2 by 2, which also makes it 4. So 4 and 4 is 8, plus 18 is 26, plus 10 also gives us 36. So there's a couple different ways when you're thinking about it in terms of graph and coordinate plane, how you can find the area of these different irregular shapes. The easiest shape to work with, if you can possibly break it down, is into these rectangles. Now that leads us into more story problems, and there's going to be 4 parts to this problem, all right? A family is installing ceramic tiles on a kitchen countertop. They want to know the total amount that they will have to pay for all of the tiles. What information do you think they need to know in order to answer this question, right? We're missing some information. Well, first, we need to know the dimensions of the countertop. Is it rectangle? Is it an L shape? Is it, a different shape? Are there any holes in the countertop? Right? If you think of your counter in your kitchen, you've got a hole for your sink. Other people have holes for other things as well. So are there any holes? How big are the tiles that they're going to buy? How much is a tile? So we've got lots of questions that we need to work with. A lot of different questions, right? And let's just start off by thinking that maybe we're just working right now with a rectangular countertop. All right. So here we go. There are 4 parts to this countertop that are not going to be tiled. A 3-foot by 2-foot opening for the sink, 2 openings that are 2 feet by 1.5 feet each for cutting boards, and an opening that's 1 foot by 2 foot for knives. What is the total area of the space they are not tiling? Why don't you pause the video here and see if you can come up with what's the total space they are not tiling. So I've written down their openings, right? They're going to have a 3 by 2 foot opening for the sink, so that's a 6-foot opening, plus 2 openings for the cutting boards, 2 feet by 1.5. So 2 by 1.5 is 3. Need a second one of those for the other cutting board. And then the knives are going to have a 1 by 2 foot opening, which is 2. So if I add all of those together, 6 and 3 and 3 is 12, 14 square feet. That's how much they are not going to be tiling, right? If I have a whole rectangular countertop, there's going to be a sink that they're not going to put tile on. There's going to be a smaller cutting board area. They're going to have another cutting board area, and then another smaller part for their knives. So those spots, if I color them in, are going to be blank. They're going to be empty. And so I can't include buying tiling for them. Well, there are 4 parts that we said will be tiled. The entire countertop is 16 feet long and 2.5 feet deep, meaning if you look at the countertop from a peripheral vision, that's the length. So it's 2.5 this way by 16 feet this way. So what is the area that they will be tiling? So if it's 16 this way by 2.5 this way, the whole entire countertop would be 16 times 2.5. All right. Now, again, if you need a calculator to do that, I would encourage you to do that. I know that it's going to be 40. However, that's if we didn't have any openings. We then have to take 40 and subtract that information from the previous page that they're not going to be tiling. Subtract the 14. Meaning they're only going to be really tiling 26 square feet. So that's all the tile that they really need to buy is enough for 26 square feet. What we don't know yet is how big are the tiles and how much do they cost. I'm going to write up here that we need 26 square feet. If you notice on the bottom, each tile is going to be 1 foot by 1 foot. And each tile costs $2.20. How much will we spend? Well, if I need that 26 feet total, right, and one tile, this goes back to our coordinate plane, one tile is 1 foot by 1 foot. That means I have a 1 square foot area. And I need 26 total square feet. Therefore, we need at least 26 tiles. Now, I know some of you might be thinking, well, what if you crack one? What if you make a mistake? What if you have to cut one in half? And you're right. There's probably more that we would need to buy. But for this story problem, we're going to focus on needing to buy 26 tiles. And each one is going to cost us $2.20. I don't know that math off the top of my head, so we're going to go to our friend Desmos and figure out what is 26 times $2.20 per tile, leaving us with a value of $57.20. So they would have to spend $57.20 on tiles for their countertop with those holes. But notice how we needed a lot of different information to get to that final answer. All right, let's look at what another type of an example where we have missing measurements. An airport runway is 2.5 miles long. How many square yards is the runway? So what additional information do we need to know? Well, how wide is the runway? They don't give us that, right? I don't know the width. All I know is that this runway for the airport, if I draw it this way this time, is 2.5 miles. 2.5 miles. What we don't know is its width. So let's put an X. They're also asking us how many square yards. Well, that means we need to convert something. How many yards are in a mile? Right? I got to convert this into yards. I also need to know its width. So let's take a look at what other information they might give us. The runway is 1/8 of a mile wide. So now we know it's 2.5 miles long by a really narrow 1/8 wide, 2.5 miles long. They also are telling us that there are 5,280 feet in a mile. So that's feet in 1 mile. How many yards in a mile does that make? Well, remember, 3 feet make up a mile. So for every 3 of these, we have 1 yard. So 5,280 divided by 3 will tell me how many yards we have in a mile, which is 1,760. 1,760. So the easiest way to do this one is to then convert 2.5 miles into yards. If there's 1,760 yards in 1 mile, we're going to multiply by 1,760 to figure out how many yards that is. So let's go 1,760 times 2.5 miles, and we get 4,400 yards this way. 4,400 yards for its length. And then we got to figure out its width if it's only 1/8 of a mile or 1/8 of these yards. So 1,760 times 1/8, 1/8, and we get 220 yards wide. So 220 yards wide, meaning I multiply the length by the width to figure out how many square yards we have. 4,400 times the 220, and we get times 4,400, 968,000 square yards. That is the area of this particular runway. So again, hopefully you're seeing that when we're trying to be asked some of these questions, we need to make sure we have a lot of information to help us figure out the area of particular shapes. All right. The last type of problem is going to give you where they tell you that the perimeter of a certain rectangle is 24, right? So this perimeter is 24, a length and a length and a W and a W. So 2 lengths plus 2 widths has to equal 24. But then they're telling you the area, right? Find the dimensions if the area is 11. Well, what happens if the area is 11. Right? And that gets a little bit trickier, right? If the area is 11, that means length times the width is 11. Or my length is equal to 11 over W, dividing 11 by the W. And I can use this information, since it's equal to L, back up in this equation. Two of those. So 2 L over W plus 2 W's has to equal 24. And we can go through this whole lengthy process to try and figure out what it might have to equal, right? We're going to get 22 over W plus 2W equals 24, and then we've got to kind of use some other skills. Now, some of these are going to be a little bit easier for us to solve, okay? Like 36 square units, for example. Right? What are some possibilities for a rectangle to get 36? Well, I could have 12 times 3. But if I put those in for length and width, 12, 3, 12, 3, and add them up, would that give me a perimeter of 24? And it would not. What about 9 by 4? Right? 9 times 4 is an area of 36, but 9 and 9 is 18, and 4 and 4 is 8, so that would give me, what do we got? 26, so we're a little bit over. What about 6 by 6? 6 by 6 is 36. Now, a square, well, that's still a rectangle, so 6 and 6 is 12, and 6 and 6 is 24, so by guessing and checking, we may have found it. And so you may have to use a little bit of guess and check. There are other methods that we will talk about later on as we look and discover some area for other types of shapes. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.